It was the year 1931 when it all started. It was when a priest, George Lerner, published a research paper which was and still is widely accepted all over the world. I am talking about none other than the Big Bang Theory. Imagine all of a sudden such a theory being disproved. Well, this is what actually happened. Few of the latest observations of the James Webb Space Telescope caused serious problems in the Big Bang hypothesis. Even before the JWST, there were serious contradictions to the Big Bang. Have you ever thought of an alternative answer to the Big Bang? If the Big Bang didn't happen, how did the universe begin? What is the origin of the universe? This sudden move of cosmology is really a disaster for space research. So let's come to the point. How did the JWST prove this unquestioned theory wrong? The images of the Webb telescope are so astonishing to us. These breathtaking images are even a cause of panic for astronomers. Crazy? Since 12th July, the research papers published online show that the images show surprisingly many galaxies. Galaxies that are surprisingly smooth, surprisingly small, and surprisingly old. Lots of surprises and not necessarily the pleasant ones. And this is what contradicts the Big Bang hypothesis. It is not too difficult to explain why these too small, too smooth, and too old, too numerous galaxies are completely incompatible with the Big Bang. Beginning with too small, if the universe is expanding, a strange optical illusion must exist. Galaxies in the expanding space do not continue to look smaller and smaller with increasing distance. Beyond a certain point, they start looking larger and larger. This is because their light is supposed to have left them when they were closer to us. This is in sharp contrast to the non-expanding space, where objects look smaller in proportion to their distance. And smaller is exactly what the JWST images show. Even galaxies with greater luminosity and mass than our own Milky Way appear in these images to be 2 to 3 times smaller than in similar images observed with the Hubble telescope. And the new galaxies have redshifts which are also 2 to 3 times greater. And this was totally not expected with an expanding universe. Results based on the Hubble images showed that galaxies with redshifts all the way up to 5 match the expectations of non-expanding ordinary space. The JWST has also shown the same thing for galaxies of redshifts up to 12. The galaxies that the JWST shows are just the same size as the galaxies near to us. If it is assumed that the universe is not expanding and redshift is only proportional to distance. But from the viewpoint of the Big Bang and the expanding universe hypothesis, these distant galaxies must be extremely tiny to make up for the hypothesized optical illusion. Unrealistically tiny. A galaxy called GHZ2 is far more luminous than the Milky Way, yet it is calculated to be only 300 light years in radius, which is 150 times smaller than the radius of our galaxy. Its surface brightness, which is its brightness per unit area, would be 600 times that of the brightest galaxy in the local group. Its density, and that of several other galaxies in the new images, would be tens of thousands of times that of the present-day galaxies. Big Bang theorists have known for years from the Hubble telescope images that their assumptions necessitate the existence of these tiny ultra-dense galaxies. JWST has made the problem far worse. The same theorists have theorized that the tiny galaxies grow up into present-day galaxies by colliding with each other, merging to become more spread out. It is pretty straightforward that if the galaxies are colliding, they should be scrambled badly. And they did expect to see badly mangled galaxies scrambled by many collisions or mergers. But it turns out that the JWST actually showed overwhelmingly smooth disks and neat spiral forms, just as we see in today's galaxies. The data in this article showed that smooth spiral galaxies were about 10 times as numerous as what theory had predicted, and that it would challenge our ideas about mergers being a very common process. With few or no mergers, there is no way tiny galaxies could grow to be 100 times bigger. Therefore, they were not tiny to begin with, and thus the optical illusion predicted from the expanding universe hypothesis does not exist. But no illusion means no expansion. The illusion is an unavoidable prediction from expansion. Tiny and smooth galaxies mean no expansion and thus no Big Bang. The JWST uses many different filters to take its images in the infrared part of the spectrum. Thus, it can see the colors of the distant galaxies. This allows astronomers to estimate the age of the stars in these galaxies. According to the Big Bang theory, the most distant galaxies in the JWST images are seen as they were only 200 to 500 million years after the origin of the universe. Yet already some of the galaxies have shown stellar populations that are over a billion years old. Since nothing could have originated before the Big Bang, the existence of these galaxies indicate that the Big Bang did not occur. Just as there must be no galaxies older than the Big Bang, if the Big Bang hypothesis were valid, theorists expected that as the JWST looked out further in space and back in time, there would be fewer and fewer galaxies and eventually none. But galaxies as massive as the Milky Way are common even a few 100 million years after the hypothesized bang. The new images show that there are at least 100,000 times as many galaxies as theorists predicted at redshifts more than 10. There is no way that so many large galaxies can be generated in such a little time, and hence, no Big Bang. In space science, the proving wrong of theories is common, and to be honest, it is very necessary too. If we keep believing the wrong theories, how can we crack the mysteries of the universe? The Webb telescope has really changed our understanding of the cosmos, and surely we can't wait to see what it unravels next. Comment down your opinions and do subscribe to the channel if you enjoyed the video. And until next time, thanks for watching.